All right, so today we're going to be talking about exponents, and more specifically, we're going to be talking about fractional exponents. So I want to just double check. Can everybody hear me okay? Give me a thumbs up if you can hear me okay. Okay, so it looks like everybody's hearing me okay. That's good. So let's get going. So this is Math 2, Unit 8.2. And today we are talking about fractional exponents. So we're going to review, actually, as we go through this, 3 of our exponent rules. And the first one we want to talk about is multiplying the same base. For instance, if you have m to the third times m to the fifth, what does that equal? Well, you should remember that it is m to the 3 plus 5, which is m to the 8th. Whenever we multiply the same base, we simply add the exponents. 3 plus 5 is m to the 8th. All right, with that rule, that should be review for you. What if we had, let's say, 3 to the 1/2 times 3 to the 1/2? Well, if we follow our rule, that is simply 3 to the 1/2 plus 1/2, which is 3 to the first, or just 3. 1/2 plus 1/2 is 1. Well, when else do we end up with something like that? Let's take the square root of 3 times the square root of 3. What do we end up with? Well, remember, whenever we multiply square roots, we take them and we take what's underneath and we put them in the same radical, or we say we multiply them. So we rewrite that as the square root of 3 times 3. But of course, we know if we're looking for square root, we're looking for pairs. One gets out, one gets killed, and we end up with a final answer of 3. So the square root of 3 times the square root of 3 equals the square root of 3 times 3, which our final answer is just 1 to the first. So you can see these two guys are equal, which must mean that these two guys have to equal, and that's a new rule for you, fractional exponents. Okay, so we can say that the 3 to the 1/2 equals the square root of 3, and I'm going to put 3 to the first. So hopefully what you can realize is the numerator is the exponent here, and the denominator is the root. Now, of course, we can go backwards as well. If we have the square root of 3, of course, we could rewrite this as 3 to the 1/2. And that's what we're going to be doing really the rest of this unit, changing fractional exponents to radicals. All right? We'll get more into this in a minute, but let's just take this 3 to the, I don't know, it doesn't really matter, 5/3 could be written as the third root of 3 to the 5th. The numerator is your exponent, and the denominator is your root. We're going to talk more about this in a minute, but I just want to do one more example from above. If we had 3 to the 1/3 times 3 to the 1/3 times 3 to the 1/3, that equals 3 to the 1/3 plus 1/3 plus 1/3, which equals 3 to the first. That shouldn't be amazing to you. Anytime we multiply the same base, we simply add their exponents. We have the same base here, so we add 1/3 plus 1/3 plus 1/3. We get 3 to the first. And of course, we can relate that to the third root of 3 times the third root of 3 times the third root of 3 equals the third root of 3 times 3 times 3. Anytime we multiply identical radicals, in this case third roots, everything gets multiplied inside. Third root means it takes 3 to get just 1 out. So again, what does that tell us? It says that 3 to the 1/3 equals the third root of 3. The denominator is the root, and the exponent, the numerator, is the exponent. Okay, now let's go a step further and let's talk about the next exponent rule, which again should be hopefully pretty easy to you guys. If we have, let's take a letter this time, m squared raised to the third power, well, that equals m to the 2 times 3. In this case, when you raise a power to a power, you multiply. So it's m to the 6th. And if we want to get more complicated, we could say 3m to the 5th n to the 3rd raised to the 6th power. Well, what I like to say is when you raise a power to a power, you simply distribute that power to everything in the inside. So we get 3 to the 1 times 6, 3 to the 6th. M to the 5th raised to the 6th, 5 times 6 is 30. And n to the 3rd raised to the 6th is n to the 3 times 6, or 18. Okay, that should be a little bit of a review for you guys. All right, well, let's go a step further now. And before I do that, I do want to remind you of one other thing when we multiply fractions, because we're going to do that in just one second. If I took 5 times 1/3, you have to remember, in order to do that, we have to change 5 to a fraction. So we change 5 to 5 over 1 times 1/3. And now we simply multiply numerators. 5 times 1 is 5. And again, this is review from elementary school. 1 times 3 is 3. 5 times 1/3 is actually 5/3. All right, keeping that in mind and keeping raising a power to a power in mind, we want to look at this one. What if we had 5 to the, what did we just do? Let's use the same one we just did, 5/3. So let's go with 5 to the 5/3. Okay? Well, if we have 5 to the 5/3, we want to rewrite that as, we have two ways we're going to do this. We could rewrite this as 5 to the 1/3 raised to the 5th power, right? Because remember, we said 5 times 1/3 is 5/3. So here I'm saying 5 to the 5/3 could be rewritten as 5 to the 1/3 raised to the 5th power, because 1/3 times 5 is 5/3, just like we started with. But now remember, let's just take this inside part right here. We said a fractional exponent would be, you take the 5, the numerator is the exponent, and the denominator is the root or radical. So 5 to the 1/3 equals the third root of 5. But remember, we have these parentheses, so we would put this guy in parentheses, raised to the 5th power. So 5 to the 1/3 raised to the 5th power is equal to the third root of 5 raised to the 5th power. But remember, we could also write it this way. Instead of the 1/3 on the inside, this time we could say 5 to the 5th raised to the 1/3 power, because again, 5 times 1/3 is still 5/3. And then what happens? We end up with, we'll take 5 to the 5th. That's 5 to the 5th right here. The numerator is, we don't need that 1, so it's simply 5 to the 5th raised to the 1/3 simply becomes the 3rd root of 5 to the 5th. Well, where'd that 1 go? Well, really, it would be put right here, but we don't need it. Okay? So, with that in mind, let's do some examples. I know that doesn't seem, hopefully, it's not confusing, but it may be, but we're going to do some examples that will hopefully help you out. And we're going to do those examples off of the worksheet. Okay? Your homework for today is worksheet 8.2. Okay? And let me get a copy of that out. We'll go over that right now. We'll do a few examples. Of course, I'm going to do the evens for you. All right. So let's start off with this one right now. So if you want, I will take a quick little break. So if you want to print out this worksheet, you can do that. This is Math 2 Unit 8 Worksheet 2. It is your homework assignment for today. You're going to do the odds. But if you want to print it out real quick, you can do that. I'll take a second here and wait for you to print out worksheet 8.2. All right. Let me go ahead and do some examples. Of course, guys, I'm recording this, so I will post this right after we're finished here. So we have y to the equals 2x, or y equals 2 to the x, okay, is graphed to the right. Complete the table and label the points B, C, D, E, and F. So here's point A, B, C through F. We have x is 3. It would be 2 to the third. 2 to the third is equal to 8. Okay, well, if x was 2, it'd be 2 to the second, or 4. And we have, if x was 1, it would be 2 to the first, which is just 2. And if x was 1/2, it would be 2 to the 1/2, or the square root of 2, which we don't have that number. So let's just take an approximation, which I believe is 1.3. Which is 1.41, and 2 to the 0 power is 1, and 2 to the negative 1, well, you guys might need a little review of that as well. 2 to the negative 1, anything to a negative 1 power simply means put it on the bottom and make it positive. So that becomes 1/2. So label A is 3, 8. So 1, 2, 3, 8. B is 2, 4. So 2, 4 right there. That's B. C is 1, 2, which is right there. D is 1/2. And it's 1.41. And that looks pretty good. D. E is 0, 1. It's right there. I'm going to put that up there. And of course, point F is negative 1, 1/2. And it looks perfect right there. That's just a little reminder to help you remember that every equation, no matter what the equation is, can be graphed some way. All right, so this is more about what our notes were. So number 2, we have x to the 3/2 power. Here's what I like to do, guys. I take the letter, I write it. The numerator is the exponent. The denominator is the root. So k to the 3/2 becomes the square root of k to the third, which now remember, that's k times k times k, which it takes 2 to get 1 out. So we end up with k times the square root of k. All right. Number 4, is an easy one. I take the letter x to the first power, and it's the third root of x to the first. The numerator is the exponent, the denominator is the root. All right, let's take a look at number 6. We have the third root of f to the second. I write the letter. The exponent is the numerator. The root is the denominator. So the third root of f squared becomes f to the 2/3 power. Number 7, I'm going to help you out with that one. That's a tricky one. Well, remember that 5 is to the first power. So I take 5 to the 1/4. Okay, 1/4. And then I take x to the 3/4. Okay, and there's your answer. All right. Now, if you wanted to get tricky, we could also write it this way. We could take that 5x to the 3rd and think of that all as one thing. Put it in parentheses. Okay? Well, if we put it in parentheses, it's to the first, so we could say 5x to the 3rd to the 1/4 power. Okay? 1 times 1/4 is 1/4. 3 times 1/4 is 3/4. Both of these are exceptional answers. Okay, I think this is the best one. Okay, let's see. Let's go down to number 8. They want us to evaluate 16 to the 3/4. Well, if we take 16, the exponent is 3 to the 4th root. Well, 16 to the 3rd is 16 times 16 times 16. We're looking for 4th root. We can't take any of those out, but we could change 16 to 4 times 4, and this 16 to 4 times 4, and this 16 to 4 times 4. I have to remember I'm looking for 4s. It's the 4th root, so I need 4 to get one out. So a 4 is getting out. Are these two guys stuck inside? Well, let's see. What if we take 4 and make it 2 times 2? And this 4 is 2 times 2. Well, now we have 4 2s. So a 2 gets out, 3 get killed. And is there anything left inside? Nope, this guy's out, these 3 are dead. This guy's out, these 3 are dead. So we end up with simply 8. Okay, so 16 to the 3/4 power equals 8. All right. Let's go on down to number 12. Let's do number 12 and take a look at that one. So we have 64. So I always write the number first. The numerator is the exponent, and the denominator is the root. So 16 to the 5/6 equals the 6th root of 64 to the 5th power. All right. Well, how do we do that? Okay, it takes 6 to get one out. We have to remember what we have is the 6th root of 64 times 64 times 64 times 64. That's 1, 2, 3, 4 times 64. And I've got to remember this is 8 times 8. 64 is 8 times 8. All right, so I'm looking for 6. So 1, 2, 3, 4, 5, 6. That'll get just one out. Okay, got that guy out. These are all dead. Unfortunately, we only have 4 of those, but we got to remember 8 is 2 times 2 times 2. And 2 times 2 times 2. So this is one of the 8s. This is the second 8. There's the third 8, and there's the fourth 8. Well, remember, we need 6 to get one out. Well, 1, 2, 3, 4, 5, 6. 2 gets out. 1, 2, 3, 4, 5, 6. Another 2 gets out. 8 times 2 is 16, and 16 times 2 is 32 when we're all done. All right. And let's go on to the second page, take a look at a couple of those real quick. All right. So now up here on these 6, we have some negative exponents. Well, that's okay. Let's take a look at number 18. All right, well, number 18 is 64 to the negative 1/2. Well, you have to remember that a negative exponent means put it on the bottom and make it positive. So we're going to take 64 to the negative 1/2 and make it 1 over 64 to the 1/2. Then remember, 64 to the 1/2 is really 1 over the square root of 64. We know the square root of 64 is 8, so this ends up being 1/8. Okay, let's go back up to number 15. I'll help you out with that guy. Number 15, negative exponent, so we're going to convert this to 1 over 27 to the 2/3. Negative exponent, put it on the bottom and make it positive. This becomes 1 over 27 squared to the 3rd root. The numerator becomes the exponent, the denominator becomes the radical. So this we can rewrite as the square root of 27 times 27. 27 squared equals 27 times 27. Remember, we're the 3rd root, but 27 is 3 times 3 times 3. 3 times 3 times 3. This 27 is right here. This 27 is right here. We're looking for 3's, so this guy gets out. These 2 get killed. This guy gets out. These 2 get killed. And we end up with 1 over 3 times 3, or 9, 1/9. Okay. And moving on, we're almost done, guys. What about raising a power to a power? Well, we already talked about this. When you raise a power to a power, you simply multiply. So we have 25 to the 1st raised to the 1/2, or 25 first x squared raised to the 1/2. So I'm going to take the 25x squared, and I'm going to take the square root of it. 25x squared to the 1/2 is 25x squared. There's the numerator, and there's the denominator. So the square root of 25x squared. Well, that's pretty easy because the square root of 25 is 5, and the square root of x squared is x. All right, last example. Okay, let's do number 26 for you here. Well, whenever we're going to multiply a fractional exponent and a radical, we can't do that. But let's convert this radical to a fractional exponent. I take 3 to the 2/9 times 3 to the 2/3. When we're multiplying the same base, we add exponents. So this becomes 3 to the 2/9 plus 2/3. You have to remember, we can't add fractions. They have a different denominator. So we're going to change this to 3 to the 2/9. 3 times 3 is 9. So 2 times 3 is 6. So we have 3 to the 2/9 plus 6/9, which is 3 to the 2 plus 6 is 8. You add exponents and keep the denominator. Little review of adding fractions. Okay? All right. So guys, you're going to finish up the evens of this worksheet for classwork and homework. Please speak up for any help you need on these. I know this is a lot I threw at you, but it really is a review of exponents and adding fractions. So if you have questions, shoot them up. I'll be happy to do those. Keep in mind, I will be uploading all of the odd solutions this afternoon. Questions? All right, let's go ahead and get started.